Last week we finished until this part. Okay, we finished the stack. We know how to deal with the stack with at least 5 methods. So we have push, and then we have one argument which is object, and then we have pop, which means we want to remove the object, and this is to remove the last element, the last inserted element. And then we have 3 auxiliary. Auxiliary means additional stack operations. So they are top, length, and is empty. Um, I think I need to discuss what the application for the stack. So if you know about the page visited history in the web browser, so you know that every page that you visited in the web browser, it will be saved. And if you want to return back to the newest one, so we can just go to the newest one, or it means it is the top, or the undo sequence in the text editor, or chain of method calls in a language that support recursion. Stack can be used in any other data structure for algorithm, and it's also a component for other data structures. Let's say we want to do the stack with the array. Okay. So the simple way of implementing the stack ADT, which is the abstract data type, we can use array. So we can add the element from the left to right, and a variable keeps track of the index of the top element. So if we have S is a kind of list, okay, so maybe this is a stack. And then we have the index 0, 1, 2 until T. So T will be the top. The array storing the stack elements may become full. We already learned from the array that array may become full, and then there are 2 strategies. Okay. The strategy will be the doubling strategy and incremental strategy. A push operation will then need to grow the array and copy all the elements over. So if we have the push, it means we want to put the element at top, and when it grows the array, then you need to copy. So we already learned that one from the incremental and double strategy if we use the array. When we do with the array stack, we can have the performance. The performance here is the space. So the space ON means we have the place for n elements. N is the number of elements. And if we have n number of elements, then the space will be ON. For each operation, so this kind of operation means the insertion and deletion. So it means push, pop. Okay. If we want to push, it means we want to insert one element. If we want to pop, it means we want to remove one element. Because it is a very simple operation, then we can see that this runs in O1. O1 means constant. And it is amortized in the case of a push. So when you push, so it's always amortized, because we don't care about the remaining elements, we just care about the top element. So this is the array-based stack in Python. Let's see one example in the material. So you can check on your e-class. In your e-class about the array and stack, I already put two files, IPYNB. So those files are related to array and stack. So after you download those files, you can open your Jupyter Lab. After you open your Jupyter Lab, you can open the file .ipynb. You can open the stack also. Okay, so I will just start with the array first. Yeah, I think you need some time to open your Jupyter notebook, so I will just give you a few seconds. In the first IPYNB, I would like to discuss about array. So we know the array from the PowerPoint we discussed last week is a very special data structure for only a particular data type. Let's see, I have this data, and you know that this is the symbol to represent a list. So this is a list. What is a list? A list is a collection of data elements, and the data can be anything. The data can be integer, the data can be float, the data can be string, and everything can be in one variable. And the variable is the data. And we know that when we use the common bracket, it is a tuple. Okay. The same with the list. Tuple can be the collection of elements, which is from integer, float, and also string. Okay. So I just want to flashback a little bit about the list. So here is the list of triangle. Okay. I have this list of triangle, and when I call the class list and I put the string here, it will automatically separate every character into single element. So if I mention triangle, then it is a list of triangle. You can have like this list of string elements, okay? But as I mentioned to you, the list is free from the data type. You can put integer, you can put float, you can put string. However, when we come into array, it is a very specific data structure. So whenever you want to do like matrix operation, or if you want to do only the mathematical operation, then you may need to specify only integer value, for example. So you need to use array. So this is an array. We need to use the built-in array, and then we want to define the data type, because we need to specify the particular data type. Yeah, you already know from the previous slide, we have this array and we have some of the data type. Okay, we can have b, small b, big B, small u, small h, big H, I, L, and F and D. Okay, so those codes represent the data type. Let's suppose I want to make the array of integer. So this is I in the integer value, and then those are numbers of primes. Okay. So primes are the numbers that can be divided by 1 and the number itself. So after you define this one, then yeah, you can print and you can see the data here is in the type of array. Okay. So you can see the difference between the array and the list. In the list, you will see that you can start all the elements with the square bracket. But when you are in the array, it always shows as an array. And as we already learned, the array has a very fixed size. So when you want to add more elements, yeah, you need to do something. Okay? So here, I think I will use the data2. Okay, so I will run again the data2. If you want to add one element in the list, actually it is also the same when you want to add an element in the array. So if I want to append into the data2 is red, blue, and green, and I want to add yellow. So you will see the red, blue, green, and yellow. And then if you want to remove, for example, you want to remove blue, then yeah, you will remove the red. You want to remove the blue, and the remaining will be red, green, and yellow. So this is already optimized by the Python, so you don't need to do more things for this one. And let's suppose I want to insert. Okay, so I want to insert one element which is white, and I want to input it into the index 1. So the index 1 in here, because the index 0 is red. Then we will get the new data which is red, white, green, and yellow. Okay. As I use the book from the Michael Goodrich, okay, there is one function that they created to use the dynamic array. So they built the abstract data types, because this is the abstract data type. It is importing C types. So this is the C types is from the low-level arrays from the Python. And then we have the class dynamic array. We have the constructor. And then we can measure the length of the array. And we want to get the particular item. So let's suppose we define the k. The k is the index. The index is 0 until n. Sorry, 0 until n minus 1. So if you want to get any particular item in the k, then it will return the value of the index k. And then if you want to append, so it means you want to put one more element. So you can see here, if the n already full, okay, so it means the size of the array already reached the capacity, then resize. So here is using 2 multiplied by the capacity. That means we want to double. Okay, so we already learned from the previous PowerPoint, we can double the capacity, so because it will be more efficient than the incremental. And then yeah, you will have a new n. This is the new size of the array, and then you will put the object into that particular location, and then n will be added by 1. So every time the size already reached the capacity, then resize. And the resize means we want to change the array. So let's say this is B. So B is a new array, and every element in the A will be transferred into the array B. And then the new A will be equals to B, which is using the bigger array. And then the new capacity will be the same with the new C, or the capacity. There is one function, make array. It means we just want to copy. We want to make a copy of the array. And there are two more functions. The first is function insert. We want to insert an element. So k means the particular index, and then value means the object. If we want to insert one value, again, we'll check whether the capacity already full or not. If it is already full, then resize, double. If still enough, then we will do the loop until the end, and then we will shift. Okay, so if you still remember the shifting, the shifting of an array means we will shift from the k, so from the n until the k minus 1. And then for every element here, we will just shift until the index k has been filled. So the index k will be equal to the value, and then the size will be added by 1. If you want to remove, the idea is the same, what we already learned before. If it is available for the k in the array, then we will check the value. So if the value exists, then let's do the loop. What is the loop? The loop here is to find the index of that particular k. After we find that particular k, then we want to shift. So shift the hole, so the hole can be filled with the other value. And then let's put the last element as known, and then we will reduce the n by minus 1. So we already learned those stuff. This is the insertion. When we insert a value, then it will shift. When we remove a value, then it will also shift according to the number of elements that you shift. Okay, so there is no example for this one. So if you want to use this dynamic array, actually this is the basis for the list. So when you use like remove, insert, so those are this insert and this remove represent how the Python perform the operation in the array. and list tuple have also the same function like insert and remove, like this one. However, in the tuple, you cannot modify. You are not allowed to modify the element in the tuple. So the tuple is mutable. Okay. And then about the stack, there is one implementation that provided by the author of the book, Goodreads. They apply the array stack. So it is a class, okay, and this mentioned that it is a LIFO stack implementation. Okay, so do you know what is LIFO? What is LIFO? Any idea? What is LIFO? Do you still remember?
Last in, first out.
Last in, first out. Okay, thank you, Isangje. So this is the concept of stack. Okay, we already learned when we were in the first. Okay, so the stack operation, insertion and deletions follow the last in, first out scheme. So we call this is LIFO. So the code for this array stack, first is the constructor. So the constructor is an empty. Okay? There is no data. And then if you want to calculate the data, we can use one function, which is length. And when we want to find whether this stack is empty or not, then here, if the data is empty, then you will see, you will get the value of true. But if it is not empty, then you will get the value of false. Push. So whenever we want to add one element, we want to append. Okay, append means add one element. So that's what we call as the amortize, because we just want to add at the end of the element. What is meaning by top? We want to get the highest or the latest value. Okay. As we know that this is LIFO, last in, first out. So the top will be the last element. If it is empty, okay, here there is one exception. If it is empty, then say this stack is empty. But if it is not empty, then return the data -1. What is the data -1? This is the last item. And then pop. Pop means you want to get the last item. If we use the top, we just want to know. Okay, we just want to read what is the last item. But if we pop, then we remove the last element. The same with the top. We need to check whether it is empty or not. If it is empty, then mention the stack is empty. If not, then pop. We remove the element. So this is the main function. Okay. Let's use the S as the array stack. And then this operation is the same with what I explained in the PPT. Yeah, this is the same with what I explained in this example. So if you run, this will be the result. So this result so the result here, the same with the written value that you see in this example. Okay? So 2 is the length, and then 3 is the element when you pop. Okay? And the false, it shows when it is empty. Okay? And then 5, okay? This is the element that you also remove. Okay? And then is empty, true. Okay? And then when you pop here, the element is not. Okay, let me just. Okay, so when you remove this one pop, there is no element. That's why it will go to error. But in this case, we use the exception. Why there is no result? It should show the stack is empty. Okay, it means the program do not stop because we already put the exception. If you don't have the exception, then the program will stop because of the error. But because you have the exception, it continues to the next stage. So the next stage is to find the push 7 and then push 9 and so on. And you can get the result like this one, 9, 3, 4, 8, which is the value after you call the function top, length, and then pop. Okay. So this example of stack, we can see about the parenthesis matching. You know that every time we have this kind of parenthesis opening, we need to have the ending. Okay? So how we can use stack to understand that when you have the opening of bracket, you will have also the closing. When you have the opening, you will have the closing. But the position, sometimes it is not in the sequence. So maybe opening, opening, closing, closing. Or there is another kind of symbol like this curly bracket. And then this is the general bracket. And this is the square bracket. And we need to match all of them. So if there is a pair beginning and closing, then it is correct. So we need to check if it is correct or not. The third one is incorrect because we can see clearly it starts with closing. There is no opening or there is no beginning of the bracket. So it is incorrect. The fourth one is incorrect because the sequence is not in the correct order. The first start with the general bracket, but the final one is the curly bracket. And the last one incorrect because we have only one opening bracket. So this is the matching algorithm. We can use the stack, push, and is empty, and pop to understand the parenthesis matching. So I just go to this Python code to understand this one. I guess I have the Python code. Yeah, this one. So this is the Python code to match the brackets, the parentheses. So we have the lefty. It means the symbol for the left parenthesis, and righty is the symbol for the closing of the parenthesis. And then we can use the array stack. And for the array stack, it is just a constructor. So S is the object for the array. And for every element in the expression, we need to check and we need to do the for loop. So here, like for example, we want to check whether C is in the lefty at the first time. And then if it is yes, then we can push. If not about lefty, and then we need to check about righty. So if it is in the righty, then we need to check whether it is empty or not. If it is not, if it is empty, then it's false. Or if the index of C and if when we pop is not the same, that is also false. So we will do until empty. If it is empty, then it is correct. Okay. So for example, this one is true. Okay, we have 1, 2, 3 lefty and 1, 2, 3 righty. And what about this? We have 1, 2, 3 lefty, and then we have 1, 2 right section or righty. So it is false. Okay. Yeah, I guess it is the time to stop for me. So you can prepare your self for the quiz.